Okay, so this is my video for standard 0.1, which is something to do with complex numbers. So the question that I did asks us to take these, oh, this thing needs to go away. Let's just go into regular viewing mode. That's not it either. Okay, there we go. So what it wants us to do is take these two functions right here, f of x and g of x, and compute their product. So that's pretty straightforward. You just add their exponents like you would with any other exponential function, and then I show that right here. But then what it asks us to do is to describe the behavior of the function, and then that's a little less obvious because this has the I variable in the exponent, and that's just a little hard to visualize. So what I'd like to try and do is rewrite it using in terms of sine and cosine using Euler's identity, and then we can picture this function as a sine curve and a cosine curve on the real axes, one representing the real part of the function, which would be e to the, which would be here, and then the imaginary part of the function, which would be here. So to do that, we kind of need to use Euler's identity. We need to rewrite the function a little bit because you can only use Euler's identity on functions of the form e to the I theta, and as you can see, it's not quite in that form right now. So I've gone ahead and rewritten it right here so that you can see, so that we can use Euler's identity to rewrite this second part right here in terms of sine and cosine. And then I've gone ahead and done that right here. So now we can think about visualizing this a little bit. So when we graph these on the real axis, as I like to do, because I just think it's easier to visualize that way, we'll expect to see a cosine curve and then a sine curve. Both should have the same period because they have the same angle in their argument, but both should also have their amplitudes expanding pretty slowly because of this term right here, which grows exponentially in x. So I've gone ahead and graphed them in Wolfram Alpha. Let's go take a look at them. Yeah, so that's pretty much what we have. It's hard to see the expansion on this axis, but if you look at this one here from -6 to 6, you can kind of start to see a line, which is, we could not, well, it shouldn't be a line, an exponential curve. Starting right here, you can see the amplitudes getting larger as we move outwards in x. And then, yeah, here's the real part, here's the imaginary part. Pretty much exactly what we'd expect. So that is all I've got for this standard.